Hello everyone. So today we are going to solve problem number 225. Implement stack using queues. So the problem is very simple. We need to do the implementation of stack, that is last in first out. It follows leaf order using two queues. And what a queue is? Queue is first in first out. So let's take an example to see how a stack would normally work. So suppose if we had three characters A, B, C. For the top of the stack would be C. And what would generally happen in a queue? In a queue, we can push elements from the back. So A, B, C. And we can get the size of the queue and we can access the front element of the queue only. So here front will be A. And in a stack, we can get the size, we can check if it is empty or not, and also the top of the stack. So in order to implement the stack, we would have C at the top, but in a queue we have A. So how can we implement a stack using two queues? So let's see how to do that. So what we'll do, we will make our push operation costly here. So push will be costly and pop will be pop, size and top. These all operations will be constant operations. So how can we do it? When the first letter comes, we simply add it in Q1. So let's suppose we have two queues, Q1 and Q2. Next, when the second character comes, what we'll do, we will take out all the elements from Q1 and put them in Q2. So A will come in Q2. Next, we will add our input in Q1. So suppose here we have next B. So B will be added in Q1. Then what we'll do, we'll again push back all the elements from Q2 to Q1. As we know, we can add elements from back in Q, so A will come here. So till now we can see our Q1 is looking like just a stack. Elements are A and B, and in a stack also elements are A and B. Top is B, and here front is B. What happens when C is added? So when C will be added, we will first remove A and B from Q1 and we will enqueue it in Q2. So A and B, sorry, this will be A will go first, then will come A will be here, then will be B. Now we will add C in Q1 and add back this A will come here and B will come here. So we can see C is at the front, that is also at the top of the stack, A is below it. This mistake, I guess. So sorry. This will be here. I have changed it. This was B, then A, and same will be here. First B will come, then A will come. So now it's sorted. So let's see how to code this. So what we need is we need two queues. We'll initialize Q1 and Q2. Then while pushing, what we'll do, we'll first take all the elements from Q1 and put them in Q2. So while not Q1 dot empty, we will push in Q2, Q1 dot front, and we need to pop from Q1, Q1 dot pop. Then we simply need to add it to Q1, Q1 dot push, the element to be pushed. And again we take all elements from Q2 and push back in Q1. So we'll do while not Q2 dot empty, Q1 dot push, Q2 dot front, and Q2 dot. So now our push operation is completed. So what will happen in if you pop some element? So we need to first take the element from Q1, Q1 dot front. Then we need to pop from Q1, Q1 dot pop, and we will simply return the element that was popped out from Q1. If we need to return the top element, so we just need to return the top element. So what we'll do, we'll simply return front of Q1. And if you have to check if it was empty or not, we'll simply return Q1 dot empty. Let's see if sample test cases are passing. Yes, it's passing, and now we'll check. So all the test cases are passing. Now let's move to the follow-up question where it says, can you implement the stack using only one queue? So how can we do this? So if we had only one queue, suppose we have only one queue. In a normal stack, it would look like A, B, C. This is first element, second element, third element. So in a queue, what we'll do when we have to add one element, we will simply add it. When we have to add next element, we want this element to be at the front of our queue. So what we'll do, we will first add this B. So here we will add B, and we will take out the remaining elements from the front of the queue and then enqueue them again. So A will come here. So now as we can see, our queue starts looking as a stack. When the next element comes, we will simply push it, then take the remaining elements and enqueue them back. So B will come here and A will come here. So as you can see, our whole queue is looking like a stack. The front is this. So it was very simple. So let's see how to code it. So let me first clear this. So now we only require one queue. So we initialize it, and while pushing, what we need to do, we first need to push it. So we will do q dot push x, and then we need to take out size of this queue minus one elements from the front and enqueue them back. So we'll run a for loop for that. We will start from 0 and go till q dot size minus 1. Then we will take out the element at the front. So what will the element at the front? It will be q dot front. Then we will pop this element from the queue. Q dot pop. Next we need to enqueue this element back to the queue. So we'll do q dot push clearly. Now our push operation is complete. When we had to pop, we'll simply pop element from the front just like before. So we'll have int EL is equals q dot front, q dot pop and return this element. And the top expression will also be same as before. We'll simply return q dot front, and same goes for the empty. We'll return q dot empty or not. Let's check if it's running. Okay, sorry, there was a mistake. Now let's see. So our sample test cases are passing. Let's try to submit it, and it's getting submitted. So we can see we are using very less time and space also. So what will be the space complexity of this? So as we are using a single queue, this will be big of n, and the time complexity will be for each operation we are doing big of n, we can say. So it will be big of n squares if they are n push operations, and pop, top and empty, these all are constant operations, so time complexity for them will be big of 1. So hope you understand the solution. Thank you and see you in the next video.